Hello, everyone, and welcome to another live stream episode of Simplifying Network Automation with NetGrew. My name is Adrian NetGrew. So we have a special guest today, Brennan Bouchard. We're going to be talking about security focus. We'll see a bit of cloud, AWS, autoscaling, firewalls in AWS. So all kind of in an automated fashion. It's a really cool project that Brennan has put together. And I'm excited to go over it and have Brandon show you the whole setup. But before we get there, Brennan, welcome. Can you tell us a bit about yourself? What do you do? About your background? How'd you get into automation and all of that? If you don't mind.
Yeah, absolutely. Thanks, Adrian. So, Brennan Bouchard, I am a senior security architect on Cisco's global security automation team, and it's in my role now. It's really fun. I'll kind of get into the background a little bit, but we work on basically we have requests that come in for customers that have certain automation challenges. And it really is, it could be working on firewalls one day, it could be working on, AAA, different cloud providers, or a mixture of. So we get a lot of really interesting problems, and just kind of, no 2 days are the same. Um, my background actually, started out, I think, like most people who's, are in the security automation or network automation space. I was a surfer in Southern California, and had nothing to do with computers whatsoever. And was driving toward one whole life goal was being a professional surfer. And come to find out, it's doesn't always work out quite how you planned. So next best thing was to join the Coast Guard, and thought, okay, well,
Oh,
let's you know you're always going to be near the coast. That's not necessarily always true, by the way. But the thought process for teenage kid was, I'll always be by the coast, and in the water, jumping out of helicopters is going to be awesome, which it was fantastic. Coast Guard's an awesome organization, but ended up had a training accident, and ended up tearing my meniscus and ACL in my knee. And so
oh,
when you're in any sort of like flying program or aviation in the military, when you can't fly, they say you're grounded. So I got grounded for a while I was like rehabbing and going back and through. Was living in military housing, and one of our neighbors was in IT, and so it's kind of in this place where they're like, "Oh, we don't know if you're going to ever be able to or whatnot." And he's like, "Oh, you should come be in IT." And I laughed at him, and I was like, "Dude, I can like check my email and the surf report, and that's the the extent of my computer knowledge at the time." And he's like, "No, you come check it out." And so was living in Astoria, Oregon at the time, on the coast, and they were the IT for them was the help desk. So they covered basically halfway up the state of Washington down to almost the California border. And so they basically did a lot of time like driving and going. And so went and worked with them for a couple of days, and was like, "Oh, this is so bad." Um, Kind of fast forward a few years, jumped in and found that I really, really enjoyed working, you know, in IT and on computers. Had another accident, thinking I was going to go back to jumping out of helicopters, and they said, "Nope, that path has been closed." So I ended up with a job at Intel, and kind of immediately out of from the Coast Guard to a network engineering position there, and worked my way up and was a technical lead. And we used to joke that we ran marathons, 100-yard sprints at a time. It was just full tilt. There's the workload was massive, and that was really the driving force behind sort of my automation journey, if you will, was finding those ways to make enough time to get the things that we were trying to get done finished. And so we went through a lot of different iterations. Their change control process was probably the most extensive of any organization I've ever been a part of. So a lot of it was initially, how do we automate and how do we identify the things that we need, the information we need to populate that change control document? And then, okay, what if we can automate that change control? Like, what if we can just make it so we fill in the blanks and have it pull that information down. And once we got that and we understand sort of the patterns that are going through, how do we then, can we make this, run our pre and post health checks to say, we streamline this, we just hit go, it gives a snapshot of what the environment looks like, make sure that we don't. And so we kind of iterated through those processes, and it built out till we had a pretty significant project that I had been the technical lead on, and they had kind of their organization segmented out as far as like personnel were concerned from the different environments. And what I previously would do is meet with the local engineer, explain the architecture, run through all of these things, get them to go through all their change control processes, and then kind of be on site when they deploy. It would take a month and a half each time that we'd go through, and it was just like starting fresh, new each time. So we had a new deployment that we built out and kind of automation in mind, end to end, and went through. And at the time, some of our leaders were like, you guys are not software engineers, you're not, what are you doing? And in Oregon, there's several campuses, and so what would have been that same evolution each time, we ran through one of them one day and kind of had everyone on site, and we're running through, and it went through the whole thing in under an hour of like a pretty extensive, like full campus deployment, and then went through and did the other campuses the next day, like bang, 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 right after. And all of a sudden it was like the light bulb moment went off, and that same director was like, do you think you could do Dali in China, next week? And I'm like, yeah, I think so. It's much more of like a clinch. You're like, but all of a sudden is like, you see that paradigm shift, and you're like, there's no going back from it. There's the process wise, like kind of driving towards. So that was the kind of piece that really shifted my focus and career, taken from surfer kid to network automation SRE individual.
Wow, what a journey. Okay, so yeah, you're the first on the live stream, Brennan, that's with the surfer Coast Guard background that ended up in networking and automation and security. So folks, as you can see, right, it's not rocket science. Anyone can pick it up. Cool. So yes, the paradigm shift, like you were saying, and that's what we've seen with a bunch of organizations, is with people just trying to put out fires all the time, right? It's like, why don't you automate? It's like, we don't have time, right? There's no time, because there's like marathons, running 100-yard sprints type of thing, like you were saying.
Yeah.
But you got to start with something small, like the change control and the change management system that you were saying, right? Start with that, just gathering data, start automating that way, and then expanding. And then, you get to deploy a whole site within an hour. And that's when you start getting to see the breadth and the massiveness and the things that you can do with automation much faster than you would do it, manually or old school.
Totally.
Cool. Yeah, cool, Brandon. So, what are we talking? What are we gonna show folks today? Like, I know you've been working on AWS, automating firewall deployments over there. So, tell us about, how did you come across this use case first, and then why, and how did you accomplish? How did you get it done?
Absolutely. So admittedly, the kind of impetus for this effort was one of my peers was working on some of the learning labs for Terraform and deploying next gen firewalls with Terraform and using the FMC provider for that. And so we were discussing some different options, and the autoscaling deployment came up, and kind of, willing to just throw my hand there. I'm like, yeah, I'll jump in there and take a look at it. And it was kind of the peeling back the onion, where it's like, is definitely a lot to bite off, and we'll run through. But I think for so many of them, these sort of projects, is it's like, how do you, I don't know, you offend any of the vegetarians, but it's like the mantra, like, how do you eat an elephant? It's like one bite at a time, right? Like it's those baby steps of the individual pieces that start to come together and kind of forming that common goal. So we'll walk through a little bit on the background of the idea behind it and show you really when we take this. So there's a document out that is a pretty extensive one. Take a look at it, that walks through the whole thing as a manual deployment. So you can Google it. There's a Cisco deploy firepower threat defense behind autoscaling environment written out to manually do the whole thing. But it's cumbersome, right? And so
is that like the validated design, the Cisco validated design?
So here, I'll share my screen and I'll show you. So do this from here.
Because I know there's Cisco validated designs, if folks don't know, right? And this is basically, similar to this.
Yep. Can you see this one, all right?
Yeah.
So this is the reference, and we'll be going back to this as we go through the deployment as well. But one of the things that whenever I look at any sort of automation project, one of the sort of barometers that I'll use is, how much time does it take doing it? How often do you do it? And how well defined is the operation? So if you're like making a little quadrant, the things that take a lot of time, but step by step exactly what you're doing, are like your bread and butter for automation use cases. And this one, we're fortunate to have the whole process defined out. So we said, okay, well, what if we took that and just wrapped it all up, so that rather than going through and needing to create all of these things individually, the beauty of Terraform being that it maintains state, if we do that and we run through the deployment, we can remove all of the different pieces that we have as well. So rather than having lingering configuration all over the place, we can push it all out in one deployment and destroy it all at the same time. So we'll jump in here. Can you see that okay?
Yeah.
Nice. All right. So this is the infrastructure as it's going to be deployed with the environment. So there's an app VPC with a subnet and a small VM that's running in there. And then there's another subnet that's going to be for internet egress, but also to the gateway load balancer. So the traffic pattern is going to come from the EC2 instance to its egress point, which for the route table is going to be this gateway load balancer, which is then going to forward traffic through here to our auto-scaling group of next-gen firewalls that are going to then forward traffic back to that gateway load balancer, which is egress point is going to be the internet, and then it's going to come back and vice versa. So we get the traffic pattern to operate from here. And the beauty of this design is that we can modularly insert more VPCs into this and be able to leverage this gateway load balancer for multiple applications, deployments, so that there isn't necessarily a dependency on deploying a firewall or inserting it into the path in every one of these. We can share that pool of resources. And then the auto scaling allows us to dynamically scale up and scale down the quantity of those firewalls without consideration of managing them on the back end. So it allows it's traffic patterns. Maybe we're retailer and it's Black Friday and there's large influx of traffic. We can scale up those firewalls to manage that traffic and make sure that everything's still secure. And then when that traffic pattern dies down, we can restrict everything back down to the reasonable size that we use for the rest of the year.
Cool. So this is like a regular, right, trying to get your firewalls in front of your cloud infrastructure, and passing traffic through a firewall setup, a firewall cluster, we would call, or auto scaling group that goes up and down, adds more instances or removes them dynamically based on the traffic inflow, how much traffic is coming through. And do you monitor also utilization of those firewalls? I mean,
Yep.
how do you scale them up and down? You can, right?
And so a lot of those are the AWS constructs. And we'll touch on that here in just a second as well. So when we deploy everything, so infrastructure wise, that's kind of the layout. And then the benefit of deploying this in AWS is that the autoscaling groups can be defined by the number of instances, to say we want to have a minimum of, this many in this group and a maximum of, we'd say a minimum of 2 and a maximum of 10. And then how we go about scaling those, we have a lot of different options. It can be by utilization. It can be by memory, CPU. It can be by time, like we can schedule them time-wise. We can trigger them dynamically based on different characteristics as well. So a lot in the way of options that we can use using the AWS construct, so we don't have to recreate the wheel every time as well.
Nice. And can you share this link with folks? They're asking if you share with me, then I can share with them.
Absolutely. So I'll share.
So Juan, we're getting the link shared here.
And then, so this is for the reference itself. And then we'll kind of pivot over to, I just wanted to show, so just for sake of looking at it, it's very detailed, but it's quite extensive as far as all the different pieces that are going into it. And some of them require, creating certain files and Lambda functions to compile and zip them up into all this. And you have to use a Linux kernel to do it, because if you try and do it with the Mac OS, there's some file issues that you run into when it's deployed. So these odd sort of challenges that you can, run into, but the process here is well defined, right? We step by step, we can go through that. And so that was really the impetus for this Terraform project, was, building it out. So there's a public repo. I'll share the link for this one as well. And for the example, in this case, we broke it out into 2 sections. So the beauty and downfall, for the beauty of the deployment with Terraform, is that we could have done it all together and just, how to deploy absolutely everything. But you lose some of the visibility as far as when we're teaching it or explaining the constructs in different pieces. And so we broke it out into 2 separate sections. The first, and actually I'll pull it up from my IDE. So the first section that we have is just all of the network infrastructure. So deploying the VPCs, the service VPC.
Brennan, are you sharing? We still see your browser.
Oh, I thought it was sharing the whole screen. All right, let me pull that up. Thank you. All right, how are we looking now?
There we go. Yes. Can you also zoom in a bit, please?
Let me see.
It's like Command plus.
Yeah. My keyboard's a little wonky on here, so I think we should be able to do.
I think it was under view, increase font as an option. Increase font size in all editors.
Yeah, there we go. Okay, do that one more time.
All right. Yeah, that's better. That's
okay,
better.
Perfect. Still can't escape the surfer in me for that. So yeah, apologize in advance. Still a little clumsy. But so when we do this, right, we define the resources that we want to have provisioned. So our service VPC, and then the subnets that are in there. So we have a management subnet, we have an inside subnet, an outside subnet, and we have a Lambda subnet. And then we have our app VPC that has its gateway load balancer subnet and the app subnet, right? And then we have quite a few endpoints. So we have a VPC endpoint for EC2. We have Autoscaling endpoint. We have elastic load balancing endpoint, SNS or simple notification service endpoint, Cloudwatch events endpoint. There's a lot that goes into this deployment, and it really is, a lot of automation projects or CI/CD pipelines are these, Rube Goldbergs of, this running through, and you kind of watch the marble running around. And this one is definitely one of those that when you see it deployed, you'll see it all kind of come together. So it deploys the VPC, it deploys the security groups, the routing, the gateway load balancer, and all of those pieces. So when this first runs, you can see up here, it comes in 2 chunks. So the very first one runs through and publishes out all of the infrastructure itself, and actually ran this just before this call to keep it fresh. So all the endpoints, everything runs and gets created. So 44 resources were created right there. Then the next section is the actual firewall portion. So this is just sets up the infrastructure, the environment, all the subnets and everything. So on the NGFW side, we define the policy that we're going to have applied, and our network objects, the access policy, the IPS policy, the rules, all that gets defined here. And then some of this, the key pairs are for the instances themselves. So generating those, and there's an option we're using the cloud delivered firewall management center or firepower management center. If you want, there's an option or toggle to deploy an FMC with this as well. So if you want to deploy a VM running FMC on it, you can do that. This also is where that app VM gets spun up from. The launch template defines what will be referenced in the autoscaling group, which is here. And this has all the definitions. So that maximum size, the minimum size, our desired size, the health check, grace period, and then the metrics and the lifecycle hooks that we'll be using for that autoscaling group.
So I see you pass a bunch of these parameters as variables. Where do you define those variables? It's like var.asg_name, right? AWS_az.
Yeah. So in Terraform,
you have variables.tf
we have a variables.tf that has all these. And so we have all of our variables defined here, and then any of them that don't have a default value get defined in that TF vars or get passed through from there.
Gotcha.
Perfect. And then, so we do that, and then all of the different permissions that are associated for the various things. So the IAM policies for the Lambda functions and what they're allowed to interact with. So, that least privileged access, how do we restrict to only allowing specific actions and permissions for each of those. We deploy the Lambda functions themselves, and they get deployed from S3 bucket that they get pushed to. So all those pieces. And then the very last side is all of the notifications. So we talked about that, Rube Goldberg, the mechanisms by which all of these come together is using the SNS or simple notification service and the Cloudwatch eventing. So the idea is that when we deploy this, and initially for the example, when it gets spun up, you'll push out and it'll push all of the network configuration for that network side. You push out the NGFW and it deploys the policy. It creates all of the different objects and the auto scaling group and your gateway load balancer. All those pieces will be deployed. but you won't actually have any instances running. So it creates that auto-scaling group with a 0 as the value. And as soon as you set that to 1, you'll start to see all of the pieces start to come into place. So one of the challenges with auto-scaling in AWS is that in order for firepower or FTD to come up, it needs 4 network interfaces. And when you deploy something in an auto-scaling group, you can only define a single interface. So the very first action that will happen is that Cloudwatch event will be sent from the auto-scaling group to say, we've launched an instance. And we have a Lambda function that's listening to that says, oh, I see this instance is launched. It goes and actually dynamically adds the remaining interfaces in the appropriate subnets for that device, so that while it's still booting, it has those added. And as soon as it comes up, you'll see all of its IP addresses, and we'll run through it. You can see them where it starts with 1, and then you'll see them just start adding on through there. And then the rest of it is it just waiting for the device to come up and run through. And so when this whole thing gets deployed, what you end up with is, like you said, all of the VPCs running, everything there, but nothing actually being deployed just yet. So I toggled this one here. So in this GWLB auto-scaling group is where we'll have the launch template that we created. So this FTDV launch template, the security group that we referenced, the key pair. So where all of it starts to come together as far as the pieces. And then we have variables for a minimum capacity, that maximum capacity, and the desire to set to 0, but I toggled it to 1 so that it would come up, or we'd have an example that was up and running. For the instances then, we come over here and I have this instance that spun up and see the 4 IP addresses that it has on here. When all of that runs, it has 2 different Lambda functions that it interacts with. So the first is this lifecycle FTDV. And in that document, it'll have you go through and actually go through creating all of it. The nice thing about this deployment is it's all bundled up and wrapped up for you. So it just runs. You don't have to really worry about any of that. But to see what it does here, it has all of the code in here. Essentially, it just listens for that EC2 launch event and then runs through some functions to add those interfaces, this create and attach interface to that instance, right?
Mm-hmm.
And then once it's done, it sends out an SNS notification that talks to this Lambda function. So this one comes in and it kicks off and says, okay, and instance was spun up, and it will go through and validate. It checks the FMC to make sure that it has all of the components, everything is set up and ready to go as expected. Then it waits for that instance to boot and runs through the registration process. So it will run through and add the manager to that, send the API calls to the FMC, and run through and build the entire thing up end to end. So the end result is that all these pieces are working, signaling, talking to each other. But from the usability standpoint, all I did was initialize Terraform in 2 different places and applied it, and the whole thing's up and running.
Right. So you have your FTD deployed as part of your pipeline, we can call it. Then you create the extra interfaces. You add 3 more, right, with SNS and the Lambda function. Once you have that, you go and you make sure that FTD is registered in FMC, right, and it shows up over there. you also have an FMC deployed as part of your pipeline from scratch?
You can. It's an option
You
to either
can.
do that or the cloud delivered one. So we're using the cloud delivered one just for an
Gotcha.
example. So here is our instance that was deployed per this example right here. So when I ran this just before this call, this is what is up and running. So let's kick on another one. I think just to kind of walk through the steps and see it all come to life a little bit. So if I change this from, instead of 1, change it to 2, and I can toggle over here, I can see I have that one existing instance that's coming through. And now I see the new one that pops up in here in a pending state.
Mm-hmm.
And we can kind of beat AWS sometimes. So it gives us the link, but it may not have anything there just yet. All right, so it has one IP address, right?
Mm-hmm.
And this is where it all starts to come together, is now I have 2 and 3 and 4. So that was that lifecycle Lambda function that was, at work. And now it's just going to sit and wait. So if we look at the eventing for this Autoscale manager, we can watch the logs and actually see what's taking place. And it can be a little bit verbose, but from the sequence wise, you'll see it run through and then just pull for a while, waiting for that firewall to actually boot. And the beauty of it is that all this is running in the background. It's not somebody sitting at their screen, twiddling their thumbs, waiting for this to come up. We see it run through, and we see it, initiate the health checks, run through. So we see the IP addresses that it's grabbing and deploying. All right, so this one will back it up a little bit.
So for the IP addresses, you want to make sure that they're not overlapping. So as part of your Lambda function, you're just like adding a +1 for every new instance that you get.
So we don't need to define any of the IP addresses from here. They get pushed from the EC2 instance. So it's
Or
using
just specify the
AWS.
subnet basically and figures it out.
Yep.
Okay.
Yep. Totally. And then from here, so you can see the instance comes up, and I don't know, we might be jumping in midstream for this particular example, but we'll see the new one come up as it's running through here. So we can see it's talking to FMC here and grabbing details around the environment that it has. And we can see, it didn't see an instance in FMC for that gateway load balancer Autoscale instance. And then it discovers, all right, the data 2 interface is this IP. The data 3 interface is this one. It public IP, and then the private and the inside IP addresses. It knows state's running, and then it sends an SNS message that it actually is listening to itself. So this Lambda function, that it uses the SNS. Lambdas have a 15-minute timeout. So if something's going to take longer than 15 minutes, you can send a notification that it then listens to itself. So you break up those processes so that if something starts coming up to that timer, you can have it initiate another function to pick up where it left off. And that's what we do here. So we can see that the VM's launched and it finishes that, and it sends that Lambda handler for that. So it posts the message there, and then it picks up from that point and it says, okay, the VM's ready. So let's go through and start provisioning it. And it'll run through the same checks to make sure that nothing's changed in the environment. And then once it pushes the configuration, it'll show up as configured. And then it will check to see if it can access SSH on that device. And so this is the new one that we just had running. It'll sit there and poll it until it comes up. As soon as it does, it adds the manager on the FTD side, and then sends the API call to the FMC to register the device. And you'll see it then immediately come up, register, and be able to start forwarding traffic from that load balancer to the device.
All right. How much time does it take for this FTD to come online usually?
About 10 minutes. And that's
About
just the
10
boot
minutes?
time. Yeah, 10, 11 minutes. And so you'll see it just, if you want to kind of watch the paint dry, you can see it. So it pulls every 30 seconds. It'll run through, check. And so it'll run through this evolution for a little while. If we go back, we can see here, we should see it pick up.
So now when you start defining your thresholds, right, if you want to make this dynamic, this auto-scaling group, right, you kind of have to take into consideration that spun up time, right? So when you define your threshold, don't wait until the last second. Don't wait until it's like at 99% CPU utilization or memory, right? Because it's going to take you 10 to 15 minutes just to bring everything up and running. So define it somewhere at a level where it gives a bit of extra time just for the FTD to come online, for everything to get synced up, because it's not instantaneous.
Absolutely. And I think that's one of the misconceptions that a lot of people think, oh, it's in the cloud. It's just turn on and just runs. And on the back end, those are still servers, right? It's still networks. It's still all of those different pieces that we can abstract a lot of it away. And the benefit being that once this is running and you have the scaling pieces in place, it's transparent. So if you have it defined when the threshold is 75% or 80% utilization, or you can look at the sort of like the ramp up to say, okay, it's increased by 20% over the last hour, like those sort of different thresholds to say this could be outpacing what that would look like, and being able to scale it from there. Nobody's sitting there deploying this firewall. No one's there. All of that happens just automatically. So it's not, if you tune it appropriately, then it's kind of one of those that it just operates and you don't really have to think about it or work on it.
So the tuning that you're talking about, right? So where would you do it at the auto scaling group, right? You were changing that from 1 to 2 instances kind of manually, but how would you do it dynamically in automated fashion, right? How would we come up naturally?
So and these are all just the AWS construct. So in that auto scaling group, we have this automatic scaling option from here. So, and that's the different options that we have. So we can do a dynamic scaling policy. Like if we created one here, and we could do, do we want to do scaling based on, different, whether we want to do that target tracking step or just like simple scaling and say, are we doing it on, CPU utilization, the network traffic, or the request count to the load balancer. So it's kind of the dynamic scaling options that you have from there as far as attributes that are available. The other option, is then the predictive scaling. So this is using, again, AWS constructs to say, when we look at the CPU utilization, again, the same information, or if you have custom metrics that you want to include as part of that, you can have it run through, and then it will use the AWS like algorithms to identify, if we have a hard fast utilization threshold, that's an immediate trigger, but being able to turn on the sort of like predictive assessments to say, okay, we're seeing this ramp up and it is likely to overflow, that threshold based on the time parameters. So we can check how long, and then when we want to pre-launch instances, how long we want to give them before we show them as ready in that group to start forwarding traffic to.
Gotcha. And how many instances of FTD can you have in the cluster? I mean, I know with 2, because I've set this up previously myself, but can you have like what, 10, 50? Is there a limit for number of instances in the FTD cluster?
So it's worth mentioning that So we have a lab that is specifically dedicated to clustering. This deployment does not use clustering. So what we're using from here is that gateway load balancer. So we have the load balancer here. This one right here is running, and it has this forwarding target group. So the target group that's here has these devices. So this one's still booting, so it's unhealthy right now because we're still waiting for that. That's the one that we just turned on. So these are non-clustered FTDs that are, or next-gen firewalls that are sitting in this target group. So conceivably, the limit constraints, it's going to do that same sort of sticky session for traffic flows to firewalls so long as they're still available in that group. But you're not going to hit the same restrictions that you would if you were using clustering from there.
Gotcha. I see. So it's basically just the load balancing between the two FTDs and having the stickiness of the session and sending it to the same FTD in the backend for that session.
Exactly.
I see. Gotcha. And that actually makes sense. So then your threshold will ideally be number of sessions on your gateway load balancer, right? As you go from 1,000 to 10,000 to 100,000, whatever it is, then it's like, oh, I need to bring in another firewall in the backend just to make sure that I can deal with the load.
Right. Well, and it part of it then is looking at and kind of using the tools that are available and identifying what kind of traffic are we seeing. Could be sessions, it could be throughput, or it could be the kind of traffic that it is that's driving up utilization. So depending on how you have your firewalls configured, you could definitely be running them with everything turned on and enabled, and it's easy to spike the utilization, or how you have those tuned. So looking at your traffic loads, looking at the average patterns, the services and rules that you have enabled, kind of optimizing that, and then identifying which of those metrics are going to be the most applicable to defining when we need to scale or not.
And that, I mean, brings the question, how many sessions can this, and are there different sizes for FTD in AWS? I don't even know. Do you have, like how are they defined? Because they're probably in the marketplace on AWS, right? And you can just spin them up. Same thing with the FMC, FTD. They're already in AWS. You can just reserve them and pay based on utilization, on bandwidth.
Yeah. So you pay on, it depends, right? So what you're guaranteed to pay on is the size of that instance. So when we take a look at a few of these running that are in here, so these are the GWLB instances. So these instances are, where's my size there? They're C5 extra large instances. And then they're using, so every EC2 instance is defined as an AMI
Right.
in AWS. So for here, this AMI ID is FTDV, this instance. So this is what registers on the marketplace. And then it becomes a matter of the size of that instance. So that's where the cost, depending on region and the size that you have, will determine the cost there. And then the network, depending on your traffic patterns and egress traffic, will kind of determine the cost from that standpoint.
Gotcha. So there's that. Would it be bring your own license type of setup for FTD FMC? Is the license included already in the instance in the marketplace? How does that work?
It depends on the AMI. So everything that we have for this deployment is the bring your own license, and then those are added to the FMC, whether the cloud delivered or your virtual FMC that you would have deployed.
Gotcha. And then number of sessions, would it really depend on the C5 extra large? It's like the inbound, it was like a 10 gig, whatever connection that instance has. Is that the limitation then?
Yep. So that would be the limitation from the total throughput perspective of the VM. So it's like when we look at things from the standpoint or looking at the network traffic total, what the VM itself can tolerate, and then from that, depending on if you have layer 7, so if you're doing deep packet inspection, what services you have, like the different features that you have enabled, and how many rules you have can dictate if there are further constraints on how many sessions and the throughput for those individual devices.
Right. Makes sense. Do you know if there's like a list somewhere that you can check? It's like, okay, for my C5 extra large, network interface is whatever, 10 gig, 40 gig, whatever it is. And for my FTD, if I have encryption turned on, right, that's going to bring it down to like 7 gigabits per second or whatever it is. If I have, more than 1,000 rules in my policy, that's going to bring it down to like 5 gigabits per second. If I have layer 7 deep packet inspection turned on, that's going to bring it down to like 2 gigabits per second. So I am getting 10 gigabit as my interface as coming through throughput of traffic coming into my EC2 instance, but right at the end of the day, I can process realistically with all these features just 2 gigabits per second, let's just say.
Exactly. So I will double check and send you the link there if I know that there was. I don't know if it's still available, so I'll double check on that one.
Yeah, because I remember seeing something like this a while back, but it was not AWS instance. So it was like, hey, if you have a FTD appliance, right, you get your box, and this is throughput, and if you start enabling features, then the throughput will go down to this. All right, but interesting.
Yeah, absolutely. And so just kind of circling back on that traffic flow. So for each of those, that interaction, right? So the piece that we have and kind of that modular design is we deployed this, well, we kind of did it all as one, but once that service VPC was deployed, the idea would be, any other services or any other, applications that would be consuming the security services would be, another VPC on here. So part of it would be identifying the profiling what that traffic pattern looked like to see from a load perspective, getting an idea, even for so many of these. So when we version these out, this could be an entire deployment for this app VPC. We should have a pretty good understanding of what that looks like. There may be those transient periods where we need to, we're pushing out a new version of that application and we're going to deploy the new one. And then once it's up, remove the existing. So kind of identifying those sort of things. And then maybe that's something that you schedule as part of that. So when we looked at the auto scaling sort of options, maybe those are when we scale up the resources so that we can run that, make sure that everything is for both of those environments is up as it stands before we remove the other and then scale it back down. So lots of different considerations, but kind of giving you that flexibility as you run through.
Right. So then, right, Brennan, you showed your Terraform plays and they're running. What if you have already an AWS setup and you're just trying to add the Cisco firewall and auto scaling group component So you're like in a brownfield type of setup. You have your AWS setup. You're just trying to add the Cisco firewalls and that VPC. How would you approach that then?
For sure. So what I would do initially is taking a look at, so on the VPC side, it deploys two, right? So there's the service
Mm-hmm.
VPC. This is what you would still be deploying. And then this app VPC, you would need to still reference it. So rather than creating that app VPC, that may be a data source for the VPC ID. And then if you already have a gateway load balancer, and likely you already have the app subnet. So the VPC definition or that resource and the app subnet would likely get turned into data sources. You'd still probably need to create the gateway load balancer subnet unless you already had a gateway load balancer. And then the security group. So for these, if you already have them defined, again, it would just be changing instead of a resource creating them, you would be doing a data source to get the ID values that you'd then reference later. The routing would only be specific to, so you instead of routing for, so all the stuff for your service VPC would remain, but the app VPC subnet routing, that gateway load balancer, you need to know. So this is where you would, instead of referencing what you created, you reference that data source for the existing VPC, and then setting up your route tables to just map to your existing app subnets rather than the one that we created. Beyond that, so those would be the changes that would be made on the network side. On the autoscaling side, everything here happens within that service VPC from that standpoint. So we set up the app VPC just so that we have something running in an example. I think with the exception of the static instance, I believe gets deployed. Yeah, so you'd remove this app resource from here. So you wouldn't spin up that little app VM for testing. But other than that, everything else would stay the same.
Nice. Yeah. So I mean, you can definitely reuse and just remove the test VM over there, and just add your app VPC, right? Whatever your application or multiple app VPCs, whatever it is. Make sure the routing is in place to forward from that VPC now to the new service VPC, where you have your FTD, auto-scaling group, and the devices. Cool. All right. So that's, definitely doable. Either if you start from scratch or you already have a setup, adding the FTDs, you can definitely use, what Brennan has put together here.
Totally. And kind of two more plugs as far as resources go. So the Terraform module is available on the Terraform registry. So we'll get the link shared for that. And then all the resources that we use. So the AWS is obviously defined on the Terraform registry as well. So anything that's referenced in that deployment, but for anything that you want to do, any changes or any pieces there, you can take a look at, and it'll define, the resource structure, what's required, what's not. So all of that, if you wanted to make any changes, are documented and defined with the samples you can grab and use as well.
Nice. Is there an Ansible collection for these two, Brian? Do you know?
There sure is. I was actually just doing a demo on this earlier. So the Ansible collection is essentially a wrapper for, so let me just Google it. So the FMC Ansible collection here is a wrapper for the API. I know we're coming up on time, so we'll scream through it a little bit, but it has samples for the configuration objects as well. And then each of these, when we take a look at the different operations, so once you install it, and you reference that FMC configuration, in the API spec, the operation ID value for each of those API calls is what defines what that activity is. So everything, the task is FMC configuration, but this get all network objects, it actually scans the API document to see what are valid query parameters, what are the valid or required path parameters. So all those different pieces. So anything that's outside of the sample, you can, any API call that is published for FMC is available in the Ansible module as well.
So yeah, that's the beauty of open API specs, right? Because once you have your API defined in a following, in this case, the open API spec, then you can use a bunch of tools out there to generate Ansible collection, or Terraform provide the resources, or kind of in an automatic fashion. That's why it's critically important when you start developing your API or your application, make it API first, and make sure you do use a standard, because make it much easier for you to generate all these tools, right? Collections for Ansible, or resources for Terraform, or Pulumi, whatever they're using. All right, it's much easier to get it going.
Totally
Brian, do we want to go and check to see if the second instance is up and running?
Yeah, it looks like so. We are not receiving any traffic just yet. We'll refresh and see if coming through. I don't have anything sent. I don't have any traffic sent from there. So we're getting alerts that we're not getting any traffic sent from it. But we do see that we have both devices are up on 7.2.5, and we have this multi-cloud access policy deployed from them. So now, just before this, we had one instance, pushed it out, and we should be able to see then as well if we jump over to our load balancer and we take a look at the forwarding groups, our target group from here. We should see, all right, so we have 2 healthy firewall instances sitting behind our gateway load balancer, ready to process traffic from our instance. They're getting alerts because we haven't sent any traffic through there just yet. But otherwise, we have, we just auto scaled that deployment from 0 to 1 to 2, and we'll tear it all down here in just a second as well.
Nice. All right. So we've shared the GitHub repo, right? That's public, folks. If you want to have a look, that's Brennan's repo, Terraform-AWS FTDV Autoscale. You can, if you're just getting started and you have a greenfield environment, you can take that and start deploying. If you have a brownfield environment and you already have an AWS set up and you just want to add the FTD component with the auto-scaling group, that's also possible. We've talked about that too. The gotcha that you should be aware of is that you need to have 4 interfaces on your FTD once you bring it up. So by default in AWS, there's only 1, right? In that marketplace image. So if you instantiate it and you're trying to bring it up and register it with FMC, it's not going to work. The gotcha is that you have to have 4 interfaces, right, Brennan? That was the thing. You create that with the Lambda function. Those interfaces, you add them, you make sure that they're there. You just specify the subnet. IP addresses get assigned automatically from that subnet pool. So don't need to worry about that. Then be mindful that you need to wait 10 to possibly 15 minutes for the FTD to come online. So as you define your auto-scaling group, keep that in mind, your thresholds for when you want to bring these devices in, because it's not instantaneous, okay? People might think, and expectations today, right, especially when I want it right away. In this case, keep in mind that it takes a bit of time for them to come online. So if you're getting hit with traffic, all of a sudden you're going from 100 to 1 million requests, right? and you need this auto-scaling group to kick in as fast as possible, keep in mind that there's some time needed for this. Can you have them actually pre-populated and kind of have them just deployed but stopped your instances, Brennan, and just turn them on? Is that an option?
So the caveat with that is you could, like, from a conceivable standpoint, you could. The challenge that you run into is the public IP address when you stop the instance will get dropped. And when it comes back up, the registration's based on that public IP address that it sees. And so you end up with this situation of how do we manage the IP address, and do you have static IPs defined for all of those different instances? So conceivably, yes, but you do have run into some caveats there with just AWS and how it functions.
Or there's an option to buy these IP addresses. You have it reserved for you, right? It's just an extra cost. It would be, hey, I want the same IP every single time. You buy it, a public IP, and then it stays with that instance, basically. So I think it should work.
Yep.
All right, so we're a bit over time here. Any final thoughts, Brennan? Thank you so much for showing this. This is a really cool demo.
No, I appreciate the time, Adrian. It's been fun, and yeah, I think this one definitely goes from 0 to 100. I think for a lot of the automation stuff, but just for anyone who's watching, taking a look at it, it's those incremental steps. There's tons of resources. Developer.cisco.com. There's so much material out there. I think it's kind of framing the what's possible, and then walking it back from, okay, if I know what the end goal is that I'm shooting for, what are the bits and pieces that I can incrementally step through to make that happen, moving in a consistent direction. So it's all a process. Enjoy it, have fun.
Perfect. Thank you so much. Thanks, Brian, again. Thanks, folks, for joining us today. We'll be back next Wednesday. We'll bring back Jean-Eric, and we'll talk about Brownfield Cisco ACI with Terraform. How you import brownfield environments. So it's going to be a cool session. We're looking forward to that one. Join us next Wednesday. And that's it, folks. Thanks for joining. Take care and see you in the next one. Thanks, Brennan.
Thanks, everyone. Thanks, Adrian.